This is a simulation of trying to build some atoms off phet.colorado.edu. This is a very useful website with a lot of simulations for physics, chemistry, and biology, anatomy, a lot of good stuff in there, fun to play around with. So this helps the visualization of the atom that's part of your atomic imagination. It's going to produce two-dimensional static images that of protons, neutrons, and electrons. So let's kind of pick an element that we're going to build right here. And I'm going to build a carbon atom. So finding carbon on my periodic table, carbon is defined, every atom is defined by the number of protons in the nucleus. A carbon atom is 6 protons. When Mother Nature made elements that had 6 protons in the nucleus, we decided to name it a carbon atom. There's other things I can click up in here. Now, stability. Now, there are also neutrons that are in the nucleus of an atom. Now, 6 protons together is very unstable. Let's add some neutrons and see what it takes for it to become stable. All right, so 6 neutrons and 6 protons, that little ratio of 1 to 1 produces stability there. That ratio of 1 to 1 protons and neutrons persists throughout the first 20, 25 elements. As you get higher up in atomic number, that ratio changes from about 2 to 1. It's a portion of nuclear chemistry that we don't discuss in Gen Chem, but I do want to note that 6 plus 6 equals 12. And if you look at your periodic table, the mass, the average weighted atomic mass is 12.011. Not a coincidence. Okay. Right now, this carbon atom has a net charge of plus 6 because it has 6 protons and 0 neutrons. Excuse me, 0 electrons. Let's add electrons to this. Now, what's great about this model is there are 2 railroad tracks, and if you just kind of dump the electrons in there, they kind of autofill. The innermost ring can only accept 2 electrons because it's a small radius, a small diameter. This is a static 2-dimensional image. The kinetic 3-dimensional structure is part of your imagination. Note how these electrons do what they're supposed to do. 2 negative charges are not happy with each other, so they immediately spread out. We now have a plus 4 ion. If I add some more electrons, they're going to go to the second ring because only 2 can fit in the innermost ring. And see how these electrons are also spreading out. Now, with this last electron here, we have a neutral 0 charge atom because the protons and electrons are equal in quantity to each other. I encourage you to kind of play around with this. Oh, here's the mass number. When you do it right there, the mass number is the sum of the protons and the neutrons. So if we remove a neutron, we see the mass number decreases by 1. We add that neutron back, mass number of 12. I hope this helps. Thank you.